These are the notes for adding and subtracting polynomials. We took a look at this when we were working on our multiplying with our variables and our exponents. So we're just going to kind of go back and review. So it's important to remember what a like term is. And we've seen this once again before with the radicals. And remember, like terms are defined as having the same variable and the same exponent. So for example, x squared and x squared are like terms. X squared and an x are not like terms. Even though those two examples have the same variable, they both have an x, they don't have the same exponent. So therefore they are not like terms. All right, and keep in mind when adding and subtracting polynomials, you add and subtract the coefficient. That is the number in front. So something you've got to remember for adding and subtracting, don't change the exponents. You can only combine them when they have the same one, but you don't change it. When we just finished our multiplication, and then we could multiply and divide anything, and we did change our exponents. For adding and subtracting, you can only combine them when they have the same variable and exponent, and you do not change the exponent. All right, so for adding polynomials, go ahead and remove your parentheses and rewrite it, and then just combine your like terms. Okay, so first in this example, you see I have parentheses around both polynomials. So just remove them and rewrite the problem. If you want to write like terms next to each other, like if I wanted to rewrite this as 12m squared plus 8m squared, so I put my like terms next to each other, that's fine. Just please be careful if you're moving things that you're moving the signs accordingly as well. And we'll take a look at that in another example. But you don't have to do this step, okay? You don't have to. So after you rewrite it without your parentheses, what I like to do, one second, I'm just going to erase that so I have a little more room. Okay, a 5 here. 12. Okay, so what I like to do is I like to kind of box things. So 12m squared goes with 8m squared. Why do they go together? Because they both have an m squared. So those are a pair of like terms. So when I'm adding them, I'm just adding the numbers. And sorry, I should have pointed out that you want to include the sign before it. Okay, so that's a positive 8. So 12 plus 8 gives me 20m squared. I did not change my exponents. All right, and then the positive 4 and the positive 5, those are like terms because they have the same variables. They don't have one. So plain old numbers are like terms. So 4 plus 5 is 9. All right, I can't combine anything else, so that is my final answer. All right, taking a look at B, I'm going to go ahead and rewrite them again. So I have 6s squared plus 3s plus 7 plus, oh, is that a 2s cubed? Minus 6s minus 4. All right, so this is the only s squared, okay? This is an s cubed, so I'm going to go ahead and give that a squiggle. So I just like to make different, shapes and match them. My plain s's without exponents go together, and then I'm going to triangle just the plain old numbers. Okay, so now when I'm combining things, I got to match. All right, and something I want to try to remember is when you're writing your final answer, you always want to go from the biggest exponent down to the smallest. So for example, my s to the third power is going to go first in my answer because it has the biggest exponent. So I have 2s to the third. Okay, once I've used something, if it's longer and there's more things to take a look at, I'm going to cross it off so I know it's done. My s squared, I have nothing to combine with because there is not another square. All right, now my s's, I've got a positive 3 minus 6. So I'm doing 3 minus 6, or 3 plus a negative. It's the same thing. That gives me negative 3s. And then I have positive 7 minus 4, which gives me a positive 3. So this is my final answer. All right, what I would like you to do now, please pause the video and have everybody work on C and D on their own. All right, in about 4 minutes, please play the video again so they can check their answers. Thank you. All right, so hopefully everyone had a chance to try these on their own. Okay, so my first example, I just, got rid of my parentheses. When I combine negative 3x squared and a positive 7, I got positive 4x squared. When I combined negative x plus 7x, I got 6x. When I combined 8 and a negative 1, I got 7. All right, in my next example, same thing, 2x squared and negative 9x squared gave me negative 7. Please be careful of signs, folks. Negative 11 and negative 2 give me negative 13. And then negative 4 and negative 15 give me negative 19. So please just be careful. All right, subtracting polynomials. So subtraction is the same thing as adding the opposite, okay? Adding the opposite. 10 minus 4 is 6. 10 plus a negative 4 is still 6, okay? So we get the same thing. So for subtraction, remove the parentheses from the first expression and rewrite each term. And you can ignore this phrase right here. Okay, so rewrite the parentheses from the first expression. All right, number 2, this is the important step. When you remove the parentheses from the second expression, change each term to its opposite sign. So really what we're doing is we are distributing our negative through. All right, and then combine like terms. So let me show you what I mean by that. So see how this is a subtraction problem? I have a minus sign in between my two parentheses as opposed to a plus sign. So I'm going to keep this first set just like it is. Now for the second one, what I'm really doing, guys, is we're distributing the negative. We are multiplying everything by negative 1. So I'm going to change the sign. So this was a positive 5, so it's now becoming a negative 5x cubed. This was a positive 2, so it becomes a negative. This was a negative 2, so it becomes a positive. The most common mistake people make is that they only give the sign to this first term, and they forget to give it to the others as well. So change the sign of everything in the second set of parentheses when it's a subtraction problem. And now we can combine our like terms just like before. So I have 2x cubed minus 5. So 2 minus 5 gives me negative 3. 4x squared minus 2x squared gives me a positive 2x squared. Negative 6 plus 4 gives me negative 2. And that is my final answer because nothing else can be combined. All right, in problem B, we're going to do the same thing. Go ahead, rewrite the first set. Change the signs of everything in the second one because we're distributing that negative. So that's a negative 3c squared, a positive c, and a negative 1. And then from here, we combine. So I have c to the 4th, which doesn't have any buddies. I have a c squared, doesn't have any buddies. Positive 2c with positive c, and then 3 and negative 1. Sorry, that's triangle. All right, so 8c to the 4th minus 3c squared. 2 plus 1 is 3. 3 minus 1 is 2. All right, so at this time, please pause the video and allow everyone 4 to 5 minutes to try these two on their own before you press play again so they can check their answers. Thank you. All right, go ahead and take a look. In the first one, if you notice, the x squareds cancel each other out because positive 6x minus 6, bye-bye. So I have negative 4x to the 3rd. My x squareds are gone, so I don't need to write 0x squared. If you wrote 0x squared, that's fine, just not what we would normally see. Negative x is by itself, and then negative 4 plus 8 is a positive 4. All right, in D, 3x to the 4th, I got that from adding x to the 4th plus 2x to the 4th. Negative 7x to the 3rd doesn't have a buddy, and then 16x squared minus 7x squared gives me a positive 9x squared. All right, now please go ahead and work on this practice either by yourself or with a pal. All right, be careful on number 10, kind of applying what we're doing. Think about what it means to have a perimeter. When you are finished, there are answer keys where you can check your work.